Okay, in this video, I just want to highlight a couple things that I really want you to pay attention to as you study for the final. In chapters 1 and 2, that was just kind of getting our feet wet with the whole idea of statistics and so forth. You kind of get lost in a lot of different definitions there. Of most importance, I'd want you to definitely know the difference between a population and a sample, also between the parameter and a statistic. Also that a sample is pulled from a population and we calculate with the data from the sample in order to make projections about the population. So that's pretty much that in a nutshell. I don't want you to get too bogged down in the other definitions there other than being able to read through and carry on a conversation about it. In chapter 3, that's where we got into, calculating mean, median, mode, and so forth. I definitely want to make sure that you can implement the range rule of thumb. You recognize that the range rule of thumb, we're looking at data that falls 2 standard deviations below and 2 standard deviations above the mean, that 95% of our data will fall in that range. That is what the range rule of thumb is. And number 7 on here, you actually get an opportunity to practice that, calculating the minimum and the maximum in your range, using the range rule of thumb. Also, that's where we got into really being introduced to z-score and calculating the z-score. We got farther into z-score when we got to chapter 6, so probably chapter 6 is where you're really going to dig into z-score. In chapter 4, that was our probability. I definitely want to make sure that you know how to deal with complements. That's what I'm getting at number 4 here, is calculating complement percentages. Item number 8 talks about the definition for conditional probability, but it's basically the probability of an event occurring given that another event has already occurred. You generally have that if or given that indicates that you're dealing with conditional probability. Okay, number 9 here is you're actually calculating the complement probability. Here was just a regular two-event dependent probability in number 10. Number 11 onward, or through number 18 at least, in this review deals with a contingency chart. Make sure that you know how to calculate both any of these probabilities, but here I wanted to point out number 15 has that given, who did not wear a helmet, given that the subject had head injuries. So you're looking at only the head injury column and then looking at the ratio of who did not wear a helmet, or did not wear a helmet compared to the total. So just keep in mind that you know how to use conditional probability. I feel like I'm going over this way too fast, but just want you to zero in on a couple things. Chapter 5 is where we really got into expected value and binomial distribution. So if you were given a probability distribution with varied probabilities for different random variables, multiplying these products here and adding up to get the expected value. The other part of chapter 5 was that binomial distribution where you are given a specific number of trials and you're speculating a certain number of successes and then the probability of each success being consistent. So number 5, you're actually calculating, you're using that combination component here. You're looking at we're looking at exactly 7 successes, and so this is the probability of success, so it makes sense that that's going to go to the 7th power because we have 7 independent events that have that probability, and then we have 2 other events that have the complement probability. These 2 add up to be the total 9. Just make sure that you can use that probability binomial distribution to calculate probabilities, and I won't ask you to do one where you're doing several and adding or subtracting them. Also, we talked about the range rule of thumb with a binomial distribution. That was another opportunity to practice that. We got into chapter 6. We really went farther into the normal distribution. Number 8 on here is you're actually reminded again of calculating a z-score. And then we went into looking at z-scores and calculating range of z-scores. Here I did this by hand. This is another one that you could have done on StatCrunch, and I think there was something very similar to this on that very first page that we did in the previous video, so I won't go through that again. Here we were finding another way where we were finding the difference, doing this by hand. You could also look at the t-chart or the z-table to get those probabilities that are associated with these z-scores, and then finding the difference. Let me see what else. This one here, you're actually looking at, an application of the z-score, number 13, where you're calculating the z-score and then looking for the probability. And then here we had to use the complement because we were looking at that phrase, is more than 10 feet long. So you had to deal with the complement. We've got a similar application with 14 and 15 here, but number 14, you're looking at college, the expense, room and board expense at a college, given an average and a certain standard deviation. Plugging all that in, giving a scenario, we're looking for room and board less than 9,000. That was just identifying that z-score and then finding the probability that is associated with that z-score. Because this is less than, it's just straight up. But if this would have been more than, we would have done what we did up here where we had to take this probability away from 1. So just make sure you can do those less than and more than probabilities given after you've calculated a z-score. In number 15, you were working with the central limit there because we're dealing with a sample of 40 colleges and plugging in the information. We have to make an adjustment to our standard deviation. So that's the adjustment that we make, and then we need to interpret that. Okay, so that brings us up through chapter 6. Then we got into confidence intervals and hypothesis testing. These couple questions, make sure that you recognize the definitions. I think we use these terms so much, and I want to make sure that you recognize the definitions and know how they can recognize those, not just how to implement that. So definitions for confidence intervals, hypothesis testing, and then there's 3 examples here where you're doing an interval. You can look those over, but definitely back down to the bottom of the page here. Definitions for test statistics, significance level. That's an easy way for me to test your knowledge without getting into the nitty-gritty, so definitely know those. And then we got into our hypothesis testing. This first one is on proportions. There's a multitude of examples that I could have pulled. I just pulled one and we did it top to bottom. I'm not going to ask you to do that kind of scenario on the final exam, but you might, just have to give just the final conclusion or calculate just the p-value or the test statistics. So my examples and the way I've tested you up until this point was just giving you one problem and you showed that you were proficient in all aspects of it. Whereas on the final exam, you're going to be given different scenarios and you're asked to give one component. So definitely look over these examples. For proportion, we have 1 sample and 2 sample. And then going into the means, just make sure that you can do each of those components if you were asked to do that separately. And then we get into the last scenario where we're on variance and standard deviation. Definitely the definition for degrees of freedom, that we use the degrees of freedom when we're working with the t and the chi-squared distributions. The f distribution, what that's all about, looking at comparing 2 different sample variances. And then chapter 10 is where we got into correlation and regression. Definitely look over those notes. This is the only place that you're being tested on that, so the notes for chapter 10.1, 10.2, and 11.1 are definitely worth looking over. I think these review questions are probably a tad brief. But R is basically that correlation coefficient. It can be anywhere between -1 and 1. And -1 means that it has a strong correlation where one variable is decreasing as the other one increases. This one, if it's a positive, close to a +1, that means that it has a very strong, as one increases, the other increases. But if it's at 0, there's no correlation. But we know that R runs in that range. The stronger the correlation, the larger the absolute value. That's what I was trying to explain here. Correlation and then the coefficient of determination. Remember that the coefficient of determination is basically your R squared, your correlation coefficient R squared, and that is an indication as to how much the relationship explains the variation. So in this case, I'm trying to find the coefficient of determination given this r of 0.46, so I'd square that to get this outcome here. Correlation coefficient is 93. In other words, 93% of the variation between these two variables can be explained by this relationship. That means that if I needed to square this to get 0.93 squared would be 80 something, 0.8 something, and that would be my explained. I need to take that away from 1 to get the unexplained. And then also just plugging in, and basically your straight up algebra trying to find expected values. But definitely look over your notes on 10.1, 10.2, and 11.1. 11.1 was, the testing for goodness of fit. So, and we did one of those on, I think, the second page of the review. So definitely look that over.